Good afternoon to our next webinar today. We are going to talk about data integrity and self-healing built-in features by design in JovianDSS v7. So our agenda for today looks like introduction to demo environment. We want to see how we will provide the testing. We will talk about the metadata and the data check-summing, self-healing demonstration. So we will emulate data corruption, and we will show how the system is able to repair the data corruption on the disk. We want to talk also about the atomic transaction rights, and this is important because our pool will be always consistent on the disk. So even if we will emulate the power failure, we will see that we don't need any data repair and a file repair utility. After reboot, the system is up and running at once. So our feature set, on every webinar where we talk about feature set, we marked one or some of them with red color, and that's the focus of our webinar. So today, the very first point, data integrity, it's our focus. And on other webinars, we talk about other features. So that's the focus of today. Data and metadata check-summing. What does it mean? It means that everything what is committed or written to the pool is so data and metadata has a corresponding check-summing data. So checksums are kind of hashes which are representing the data. So when we are reading, application is reading, then we'll be also calculating this checksum and will be comparing with the stored one. If it happens that it will not match, so the automatic repair will start repairing this data, and the data will be provided from the mirror set or from the parity disks, right? So in such case, application will not notice that it was trying to read corrupted data, but the system automatically will move to the proper data and will automatically repair the corrupted data. This will happen when we are reading corrupted part of the data. If we will not read this data for the long time, so we have the scrap utility, which on schedule will, on the regular basis, let's say once a month, will read all the data stored on the pool to just emulate reading. So just emulate the situation where you will be calculating the checksum of the data which is residing on the disk. Atomic transactions rights means so every 5 seconds by default so-called transaction group is formed. So data is cached in RAM, and everything what is cached in RAM, if data is set to synchronous operation, it is also logged to the write log to protect the data in the RAM, cached in the RAM. So after 5 seconds, so-called transaction group is completed, and this transaction group is in atomic way as a transaction written to the pool. So after writing all this data which were just in the cache, there will be kind of 1 bit changing, and then in this way there will be not possible to write incomplete transaction to the pool, because this transaction is whether valid or invalid, that will be just ignored after the coming back from the disaster or from the reboot or unexpected shutdown. Because of this design, we will not need file system repair tool. So please don't mix scrap utility and file system repair. Scrap is not a file system repair utility. Scrap is just a tool to read the data and check the checksum, right? And if the data will be not matching to the checksum, it will be repairing. But the file system structure is always okay. So that is the theory. So our testing environment, actually I show here the cluster, but we are using to this demo one single node of the VMware node, and we have the Jovian as a virtual storage appliance installed on top on this. So it is exactly the same demonstration environment as on the previous webinars. So let us switch to our demonstration environment. So as I mentioned, we are running on our server here, we are running the VMware, and Jovian is running here as a virtual storage appliance, right? So on the VMware has a HBA adapter. This HBA adapter is configured as a pass-through device. So this pass-through device is configured here as a own private controller. So PCI device, that's exactly this LSI HBA. Because of this, my Jovian is directly talking to the HBA, and my Jovian is getting all the disks as same way as it will be physical bare metal installation, right? So our Jovian here has a two pool, pool 0 and pool 1. Okay, in pool 0 we have mirrors, right? And in pool 1 we have RAID Z for backup, right? So RAID Z2, so 2 disk parity. We run a backup here on this pool. Okay, of course, running the backup on the same system is not the best idea, but if you run the backup on the local and on other system, that will be already very good. And the running backup on the local system in many cases will be just okay. But for our demonstration, that's enough. Okay, so here we have these disks, and I have the direct access to the disk. Let's say here we have a disk SDC. That's the serial number of this disk, right? And then our goal will be to emulate a data corruption on this disk. So I have direct access via remote support to this system. Okay, and we have exactly in this listing both pool listed, and then you see the very first disk here listed is exactly the SDC disk. So what I'm going to do, I'm going to corrupt the data with disk duplicator utility. So DD, and my input file will be device 0. Okay, and my output file will be device, and I forgotten again, SDC. Okay, so SDC. Block size will be, let's say, 1K. Count, I can put 1K of the zeros on my disk, and let's say I can seek. So don't start with the beginning of the disk, but seek, let's say 10K, 100K, 1 meg, let's say 10 meg, 100 meg, somewhere in the middle of the disk. So we have written these zeros to our disk C. Okay, If something happened, do we notice anything? Depends. All these machines, maybe if they will run some reading and so on, because everything is on this pool 0, then we will be noticing some problem here and repairing process here. But we don't want to wait. So for such a situation, this is why I will run the scrub. So the scrub has a scheduler, and in my case I'm scrubbing this every day and 10 a.m. in the morning. Of course, this is not what you really need to do, but in my test environment I want to run the scrub every day. Okay, but now I start the scrub manually. So the scrub will be reading all my data. There is not so much data here because my volume is of course compressed and deduplicated. So you see my total data footprint is just 19 gigabytes. It's difficult to even agree such a small amount of data where when I go to my storage, okay, you see that's the volume data stored, which is stored here. It's almost 2 terabyte data stored, but this data is really very good duplicated. That's why we have just a 19 giga real usage of physical usage of our pool. So we are expecting that during reading somewhere we have put the zeros. So during reading, and that's the case, we have already information that one of devices experienced the problem, but applications are unaffected. So let us go and see what's going on the drive C. Yeah, and we have one checksum error. So here I have chceck-mk, the monitor, which is monitoring this Jovian. So we will expect that this monitor also will find this problem and will email this problem to us. Of course, the monitoring is doing this every 30 seconds, so we need to wait for refresh. But you see, that's exactly the case that our disk, as SCSI Toshiba SAS disk, has a checksum error. So when I will go now to our emailing, to my email, and I refresh my email, so yes, I'm getting this information already. Exactly this information I am getting per email from my monitoring system, right? So the scrub will be just finishing the job, and we will see how much data scrub was repairing. That will be probably more than 1K, because this 1K was maybe touching some more sectors. Data are compressed and deduplicated. So we have C1 checksum error discovered all the time. That's the serial number of this disk. So if we want to see, that is also listed here, right? That was the emulation of kind of silent data corruption. We can imagine that one of the few sectors on the magnetic media after maybe a factory failure or some other errors was just corrupted and no more readable. Here we have a mirrors, so this data will be repaired from the mirror pair, because the data is paired on mirrors. If this will be Z1, Z2, Z3, then the data will be repaired from the parity disks. So the scan is just finishing the scanning. After scanning, we will see in the summary the results of the scanning. So we will see that some data was repaired. Okay. And what to do in such case? So we will not want that such a disk which is having already problems is still staying, even repaired in the system. We will need to replace this with a new disk. So the data is repaired. That's the one checksum error. I have a spare disks here. Actually, they are not spare, just unassigned disks. And what I will do, I will just decide to replace this disk, which is a kind of problem disk. Okay, so let us go to the replace menu. I will select the SDB now. Okay, apply. And I will be replacing this disk with the good one. So replacing process is started. We see the replacing process here in the groups, and we see the replacing progress here in the status box. So the replacing is also quite fast, because this is not replacing the whole disk like in the regular hardware RAID controller. This is just dealing with the real data. So because I don't have so much data, this replace process takes just minutes. So we are already on 34%. Let us see what's going on here. Nothing really changed, because the disk which has a checksum is still there, and I don't have any new emails, because actually no new real event happened. The replace, it's not an event which we are emailing about it. Okay, so we see it's already almost, yeah, it's exactly 50% of the disk replaced. Because this is very fast, so we will wait until disk is replaced, and we will see what kind of event will be generated and what kind of email we will have afterwards. Okay, this process, if you Google and find Aaron Toppen's ZFS administration manual, you will also find nice pictures shown here, which are describing this self-healing process. This is in normal case when the application will be reading and getting bad data. So the good data reside on the mirror pair. So in this case, there will be good data provided from the not corrupted mirror side, and afterwards this bad red block will be replaced with the new block, and now the data is mirrored to the new block. So this is a process which is working in the background, so it is not shown to the user. Okay, while we were showing this, the the replacing, sorry, is already completed. So this bad disk is now shown here as an unassigned disk, and if we want to remove this disk and put one good disk inside, we can click on the blink, and we can identify which disk needs to be removed from our server, right? So this blinking is identifying the disk. Also, after removing, you can check the serial number of this disk. Okay, so we are done, and let us check what's going on here on the check MK. After next refreshing period, we should expect that this warning will be removed, and that's exactly the case. We don't see any warning, and if we go to the emailing, I will just make a refresh to check for the emails, and yeah, now it's a status change from warning to OK. So that was our first message when we were seeing warning about the checksum error on this disk, and that is after repairing, replacing the disk, the situation now it's green. Super. So that was the self-healing demonstration, and also we would like to demonstrate the situation where I am, let's say, running one of the Windows machine. Here I have a IO meter running. Okay, that's my IO meter running some IO pattern on the random 8K mixed environment. Okay, some machines are running, some are not, but what happened when I will just power off? Okay, I want to power off my machine, so my virtual storage appliance, and you see after clicking on power off, my IO meter is stopped to show any activity, because at this moment the disk was kind of no more available for the system. But because of the timeout, VMware is still keeping this machine. Maybe by meantime I will again power on. Okay, so we need to wait for the reboot now, and after rebooting we will see that actually in this case nothing happened to the machine. The machine will continue to work with the benchmark. There will be no data lost or some problem with the machine. Maybe we can also observe the booting process of the Jovian. Okay. So that's the Jovian, which is now after reboot. So it's loading the image after reboot, and on our IO meter we see the problem. So let us check what's going on the chceck-MK. Yes, there is a problem. The machine was not answering. What happened in our email? Yes, we have got a new email. The machine was down. Okay, so we know that machine is no more there. So there is an action, of course, but I taken the action. I was starting the machine already. Okay, so while the machine is booting, the monitoring system is showing lack of availability of this machine. Okay, we have of course no access to the machine because machine is still not fully started yet. Okay, let us see the machine is almost booted. Still some applications need to be loaded and started, and we'll see that the IO meter is already getting access and it's starting to work again. So my Windows machine is working again, and I just need to wait for the Jovian to complete the boot. And after we see already the change on our chceck-MK. The status is showing already green. The disk summary, of course, will take some more time to check, but if I just click on the refresh, then I get the new status at once. You see now it's 1 second before was updated, and when I go to our email system and check, the situation is green again. So the event was from down to up, and then we have information that now everything looks okay. So now I go to my pool, everything works well. As I mentioned to you, we are running this ODPS, so Offsite Data Protection service, which is kind of backup. I don't have a lot of snapshots here, just last few minutes, every minute is a snapshot, and then maybe every 10 minutes, and these snapshots are replicated to another pool, right? So we have a now 16:28, so it's exactly 28 minutes past 4, and we can see that the snapshot on the destination, that's exactly the case. This is also replicated here if was any delta changes. So we have a almost continuous data replication and data protection. We have emailing notification. It was configured from chceck-summing. We have also direct email notification from the Jovian. We have a great monitoring. We have no problem after power off, power on, so the system is up and running at once. The machine is working without any problem. So that was the demo of today. We can switch to our presentation back, but that was all what we are going to show today. If you have any questions, we will be able to answer right now or chat after the webinar finish. So I would like to thank you very much for joining us, and please watch our website and invitations, because next webinar is coming very soon. So thank you very much, and bye.